like TV from Other Dimensions has a somewhat looser feel to it.
Yeah, it's got an almost improvisational tone.
Hey everybody, we're currently live. So how's everyone doing? Sorry, I'm disappearing a little bit. Decided to wear a green shirt. I see a bunch of people in the chat. Can everyone see and hear me pretty well right now? How are we doing on the seeing and hearing of Brian Stevens? I see people in the chat right now. So you should be able to see and hear me. It's going. Good to see you, Abigail, and everyone else, and Roderick, and everyone in the chat. We're going to pull up the data right here and start answering questions. Good to see you, Trey. And how would you feel if we start doing some, where'd you get a green shirt like that disappears? Magic is where I got it from, the Magic store. So, good question. It's called wearing a green shirt while being on a green screen. It's a very, very intelligent idea that I thought of. Like, I'm gonna wear a green shirt today and broadcast live on the internet on a green screen. So that is how it goes. So I'm getting the data right now. Maybe I'll show this off. So you should be able to see my screen right here. Let's just make it very, very clear. And if you have questions in the chat, feel free to ask. We're just kind of showing how to do it. I'm having trouble tabulating. Let's do the tabulate stuff right here. Is that on Kingston? I don't know. So good to see everyone here. Let's get the data. Does everyone know where to get the data? I'm currently on the Stats1 project page. This is project 2, so make sure to go to project 2 on the page. And then we're going to download the data right here. This is the data. And so can you go over how to do linear? Cool, we're going to do tabulate and then linear. So let's start with some of the tabulate. We're going to open up this data set right here. Okay, so let's do how to do tabulate in JUMP. And then we'll do linear regression next. Great questions in the chat. So first off, how do we tabulate? We tabulate by going to analyze and then tabulate. Analyze, tabulate. Thank you, Zach. You're awesome. So we're going to go to Analyze, Tabulate, and then we're going to go here, and we need to pick some variables. Now, I want to point this out. I should have a disclaimer on the screen at all times. I'm not going to do everything exactly like the project. So if you were to copy everything I do and interpret everything the way I interpret it, you'll know how to interpret stuff. But I'm not going to do the project. Well, I'm kind of doing it, but I'm not doing it. Can everyone, I want to hear comments on that people realize Brian is doing the ways of doing the project, but he's not doing the project. Does that make sense? Like, I'm not going to do the questions in the project. So if you were to do exactly what I do right now, then you're probably not going to do the exact project. But I understand. Jessica, awesome. We got this down. Let's do some tabulate right here. So the first one wants you to tabulate 2 categorical variables. Great job, Roderick. So he's awesome. Skull. So let's go here to born in Tennessee, and let's see, let's go to gender and broken bone. So this is something we did last project, I think, but we're kind of looking at the cool features of tabulate right here. And I want everyone to see right here exactly what we have. We're going to take gender and watch slowly as we take gender and put it right here in the rows. So this is kind of our first variable, hence like family economic level, hint, 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 and we drop it right there. Then we take broken bone and put it right here over N, the capital N. Now we're going to take and we're going to go to the other capital N and drop it over the table. Remember, you can pause and rewind this video. So I'm going to make a table here that has the counts, which this one has the counts in it now, also has the row percentages. And then let's try to interpret this and see what it means. We're going to make this nice and big so everyone can see, nice and big, and I'm going to bring it right down here next to me. So let's take a look at what we have going on. Okay, so we have here males versus females. And first off, we have for females, we have 59% of females have not broken a bone, as opposed to 42% of males have broken a bone. It looks like males were more likely to have broken a bone, with 58% of males having broken a bone and 40% or 41% of females having not broken a bone. So maybe there is some sort of gender relationship to breaking a bone versus not breaking a bone here. The sample sizes look to be about even for both groups. You could add them up, but we have 413 females who have not broken a bone and 285 females who have broken a bone. So make sure to look no, and this is the count. The capital N is the count. And this is how to make one tabulate right here. We'll do another example just to do another fun tabulate option. So this is the same sort of 2C question that we're doing right here with 2 categorical variables. I'm losing my mouse as we talk. And let's go here to Analyze and Tabulate. And we're going to grab two categorical variables with, let's go right here, Honors Program. Cool. We're going to put the Honors Program in there. And I usually don't do it that way because that's sometimes harder to do. Let's do, what would be a fun variable? Let's do if people have drank and whether or not they're in the Honors Program. So I'm going to make it very clear what's going on with this. And where's Honors Program? I missed it. There's Honors Program. You can always search. There's a search option on that. There we go. Let's go to N. And feel free to ask questions if you have them in the chat. We're going to do the other Tabulate one here next. And then we're going to do the linear regression next. Okay, here we are. And let's take a look. We've got it right here. I was going to expand it, but that's good enough. And what do you notice? The people who have reported an age of first drink, which means they have drank alcohol, we see that 8.33% of them were in the Honors Program, as opposed to the people who have not drank alcohol, 14.69% of them are in the Honors Program. Now, that doesn't mean if you have drank alcohol, you won't be in the Honors Program, but we see something right here where people who don't drink alcohol are more likely to be in the Honors Program. But it doesn't mean, it's just what the data is. Who knows why, but this is the way the data goes. It's also a much smaller group for the Honors Program. Honors Program, yes, is the 97 and 21 people. It is true that also more people have not drank and are in the Honors Program because there's a lot fewer people who have not drank alcohol. But this does the first Tabulate question. For the second Tabulate question, let's look at some kind of cool stuff right here. Remember, Brian's not doing the exact thing you're doing, but he's showing how to do everything on the project. So the other way we use Tabulate on this project is we take a categorical variable like, let's look at, how about, I'm going to have you guys go ahead and pick a row for me. Pick a drop zone for rows. Pick a categorical variable. I'll even make it easier. Pick a categorical variable that we should use for rows. Who has one? A categorical variable I should use for rows. This is not what you'll do on the project, but what is a categorical variable? Humans on Mars. So let's go to humans on Mars right here. I ate a protein bar and I'm like, I promise I'm not sick. It's just very, very like, I don't know, like protein bar-y. And so it was a birthday cake protein bar and I saw it and I was like, birthday cake protein bar. I was like, I'll try that. And I was like, didn't really taste like awesome birthday cake. Like birthday cake ice cream is amazing, but birthday cake protein bar tastes like a protein bar with some weird birthday cake-esque flavors. Vape safe, they're saying vape safe. We already have our categorical variable. Now we need a quantitative. I'm kind of using these options here to select and deselect stuff. This just lets me see only numeric. The blue means that it's numeric. So we have to put a quantitative variable up here. Let's see how smart the people are who think humans will be on Mars. So here's the GPAs, and we don't want the sum of the GPAs. We actually want maybe the median GPAs, hint, hint, hint. And we can compare the medians, and we can compare the IQRs. I'm going to drop this over the table. Notice when you drop things over the table, you can add another thing to the table. Does everyone see how I'm putting this on top of the table and it appends it to the table? But let's say I don't want mean, like, I don't want that. Well, one, I can hit Command-Z, but let's say I actually wanted the mean and median. I can put the mean on top of this. I think it was. Kevin. Let me check. I think it was. It had some dude on the front of it. Yeah, I saw it and I was like, well, let me just try it. I thought it was okay. It was okay. It said birthday cake, so I was like, I'll give it a shot. So we see right here the median and the mean. So it does, doesn't it, Adam? So with this in mind, do people see how to do tabulate? Leroy, can you go over how to analyze the decision tree graph? Cool. We will do that next after scatterplot, Maggie. Great question. And how to describe the association. Maggie, let me make you a mod. I think Streamlabs got mad. I don't know why. Maggie, I'm making you a mod so Streamlabs never does that again. Sorry if Streamlabs does that. We just have things on in case someone were to say something that they shouldn't say. But you're now a mod, Maggie, and it shouldn't do that to you again. Streamlabs, calm down. Don't be that way, Streamlabs. Streamlabs is what we use, and it has auto filters, and I have no idea why it did that. really, I think it was association. I have the filters set pretty high, so that way people can't do crazy things on the YouTube channel. And then we just fix it if it goes crazy. But Maggie, we're going to do that for you. So awesome stuff. Does everyone understand how to do Tabulate? This is just kind of a quick examples with some Tabulate and how to make the output with Tabulate, especially for this project. Because I know it's a little confusing, even though there's videos, there's still so many options with Tabulate. So if you guys want, we will go ahead and do some scatter plots now, and then we'll have decision trees next. So let's go ahead and hop in here to scatter plots. So with a scatter plot, you got to think, and this is a really great question. I need the help of the chat. What kind of variables do we need to make a scatter plot? What two variables do we need to make a scatter plot, which means it's a bivariate display? To make a scatter plot, what two variables do we need to make a scatter plot? What two variables? Quantitative, Sydney, nice job. We need two quantitative variables. So let's go to Analyze, Fit Y by X. And this is good because we might even do this on the last test. We have something called Tools and Techniques. And so we want you to know that a scatter plot is a bivariate quantitative display of data, and you can do a regression with a scatter plot. The regression is like the additional analysis. And so let's hop in here and let's see, what shall we do? And this is kind of hard for me not to do the project on. So I'm going to do a full regression analysis right here. I might mention additional things, but this is how to make it. And can you go over how to display? Yep, we'll do that next. Preston, we got that on the list for you. So we're going to do decision trees next, and then how to do categorical displays. So let's do, does how much someone read explain their GPA? And I want you to notice when I say how much someone reads, does that explain their GPA? Do you see how this is the X? Does someone's weekly hours of reading explain their high school GPA? Because the X explains the Y. So does how much someone reads explain their GPA? Remember, X explains Y. So let's go ahead and take a look at this graphic, and the answer is, looks like no. So you would think the more people read, the higher the high school GPA they would have, but let's fit a line. We're going here to the red arrow. Red arrows are where all your options are in jump, and we're going to go here to fit line. And what do we see? Oh my gosh, this is some horrible output. It's all right. Project can turn out this way. Now I want to mention this, especially for the graders, because I give them the grading key. I'll go, Yutang, rewind the video, Yutang, and you'll see in the video, I show that at the very start. Check that out. And if you can't see it, we'll go back to it in a little bit here. But rewind the video, and we did that as one of the first things. Great question in the chat. So if you notice, this line looks very, very what? Just look at this line right here. That line looks very, very what? Think about it. It looks very, very flat. So with this line being very, very flat, it really is not explaining the variation. What do we mean by explaining variation? If you explain variation, it would look like this. Let's talk about R-squared for a half second. Explaining variation would be a graphic where you have a line and the data points would look something like this. And now this might have an R-squared of something like 98%. And that means 98% of the variation in Y is explained by the variation in X. Exactly. The variation is literally just the spread of the points. When you have a flat line, now look at it. That line explains what percent of the variation. This counter example here explains what percent of the variation. This counter example is probably like an R-squared close to 0. Meaning that that line really doesn't explain the variation in Y. If you look, we explained it here. The line is kind of going through, and we're not missing by much. It's doing a great job. So overall, the top one explains a lot of the variation. The line, the relationship X and Y have, which is an equation made up by the line, explains a lot of the variation in Y. But in the bottom one, it explains next to none of the variation. And what does our graphic look like? You guessed it. Ours looks like basically none of the variation is being explained. So if you look here at our line, it's flat. It's not doing a good job. We have these humongous residuals down here. That's the biggest residual. You know what I'm going to do? I'm going to hold over this point. I'm just going to hold over it. And I'm going to go here. I'm going to put it right here. And I can actually tell you that this person reads 7 hours a week, and they got a 0.1 high school GPA. That does not sound fun. That is not a good day when you make a 0.1 high school GPA. Next, we get the equation of the line right here. This is just the kind of y equals mx plus b if you like that equation, or for the statisticians. Y hat equals b0 plus b1x. This is y hat. This is b0 plus b1. This is the coefficient of b1. And then this right here is the variable x. It looks like there's minuses right here. It's just the names of the variables. So we're going to fix that just to make it look a little bit nicer. And that looks like it's Q6 minus that, but that's just the name of Q6. So its high school GPA equals 3.75. And you notice the slope is very small because it's not doing a good job explaining it. Look at the R squared. I mean, this is so small. It's 0.00096. When you times that by 100, you get the percent of variation explained. Let's show one where we actually get an R squared that's decent. And we're going to go here. We're going to explain how many pets people own by how much they spend on their pets. Yep. And if you notice, there's some outliers there. Here we get an R squared of really bad again. I'm going to try again. Let's go to analyze. We'll give it another shot here. Third try's the charm. And let's see if we can explain how many times people have cheated in college. We're going to see some more outliers here with how many times they cheated in high school. I've done these before. Someone said they cheated 1,000 times. These two people cheated 1,000 times. But look, 6% of the variation, or 6.08% of the variation in how much someone cheated in college can be explained by the variation of how many times they cheated in high school. Now I want to see some people typing this in the chat. Blank percent of the variation in y can be explained by the variation in x. So let me write this again right here. This is R squared. R squared is, and we're going to bring in the orange pen again. I see some questions in the chat. Blank percent of the variation in y can be explained by the variation in x. And very important, there's your R squared, there's your Y variable, there's your X variable, and that's how we interpret there. Blank percent of the variation in Y can be explained by the variation next. I have a very strict question regarding on outlier, probably due to misreported info. Should I ask my teacher in person his opinion if I should add a second graph that doesn't contain it? Great question, Maggie. With the outliers, we've had before in the past where we remove them, but you really can't just remove outliers. It's such a problem with statistics when you get outliers. Like, what do you do with them? And so for this report, do not worry about removing them, because we've asked people in the past to do that, and it makes for very interesting reports when people start removing stuff, and it's like, wait a minute, wait, do you remove this? Do you not remove this? You don't need to remove it. In this report, you'll see some good stuff and you'll see some bad stuff. This one right here has this extreme outlier right here, and this report over here on the right, which I might be covering up part of now, has some very extreme outliers. You shouldn't get points taken off. I write the grading keys for these, and I'll try to make it super clear to the graders that they'll probably have extreme outliers, which is something we should notice. We should notice that there's super extreme outliers. 6.0% of the variation, number of times people cheated in college, can be explained by the variation, number of times people cheated in high school. Amazing answer right there. 1,000 points. Just because X and Y appear to have a relationship doesn't mean, oh, yeah, well, actually, Foggy, great question. This is kind of, you hit upon something right there. It doesn't mean X causes Y. It doesn't mean cheating in high school causes cheating in college, but it does mean there's an association. It means that if you know how much people... That'd be awesome, Skull. We should add that in, and we're thinking about adding that in, and we'd appreciate it, but we haven't added that to the channel yet. So if you know how much someone has cheated in high school, that gives you information about how much they've cheated in college. Think about this. There's a positive linear relationship to cheating in high school to cheating in college, meaning if somebody cheats more in high school, they're more likely to cheat in college. But over here on the left, there's no association. If somebody reads more, then you really don't know what their high school GPA was. There's really no association between reading and your high school GPA. Now, I want you to think for a moment. This is a great question, and also on this project. When it comes to a p-value means statistical significant. Is the graphic on the far side of the screen away from me, on the left side of the screen, or the right side, the statistically significant line? Which of these lines The line that has a slope or the line that's flat is the statistically significant one. Any ideas? Which one is the statistically significant one? The one with the slope or no slope? Which of those sounds statistically significant? Line with the slope, Abigail, amazing answer. Let's go look at those p-values. The p-values are right here. I'm blocking the one, but let's bring it over, and you are correct. You'll notice here we get a p-value that is high for the slope. Now, you do see a p-value for the intercept. The intercept is just a point on the graphic. I'm going to have to move this over a little bit more so we can see it very clearly. And here we are. So you'll notice this is the p-value for our first graphic where the line was flat, and the p-value is high. Now, the null hypothesis for this is that the line has no slope. So you'd fail to reject the null. You'd say, well, I guess the line has no slope because I don't have evidence against that. But this p-value right here that I'm pointing at, right next to my fingers, this 0.0001 next to my fingers, is a significant p-value, which means that we see a statistically significant relationship between how much someone cheated in high school and they cheated in college. That means that what we're seeing with this line is not due to random chance. And it does seem that there is an association that the more someone cheated in high school, the more likely they are to cheat in college. Now, it doesn't mean they will. We see this person here. This person learned their lesson. Well, they got better. I don't appreciate the 2 times. This person down here cheated 2 times in college, but they cheated 1,000 times in high school. Now, this is data that we collected, and it looks like someone might have been telling a little bit of things that aren't true. But they said they cheated 1,000 times in high school and only cheated 2 times in college. So I don't appreciate the 2 times, but good job on cutting down on that 1,000 times of cheating. You do see a lot of people probably down here near the 0, 0 mark. But due to some outliers, this graphic looks pretty crazy. And I'd probably put that in my write-up. I'd probably say this graphic is heavily influenced by outliers and all that good stuff. We've done our regression output here and done a lot of good analysis on it. Who has questions related to the regression? Foggy, you are right. The slope is what tells us whether or not the line is significant. If a line, we were to look at its intercept, which is kind of where it hits the x-axis. Maybe if I do it over here, I need to go with this arm. Oh, there we go. Here's the intercept over here where you hit the 0. That doesn't control significance. Slope controls significance. Awesome. Thank you so much. Glad that makes more sense. Ask the questions in the chat. I'm always looking at the chat. You're welcome. I know decision trees were next, and then analysis of one categorical variable. And feel free to ask any questions you have related to the graphics we have on the screen. And if you ask a question we're not doing, I'll put it in the line, and then we'll do it as it comes. What do you want a screenshot of? Amazing question. The only thing we don't need here is the analysis of variance. It does say take a screenshot of everything, but you don't need the analysis of variance. I also wouldn't have points selected like this. You notice how that looks? I would click in here, and if you have points selected, they'll dim out everything. So click a blank space. If points are colored, you can go here to rows and clear row states. So if you had put some sort of coloring from a decision tree, you can remove the coloring with the rows clear row states. And that'll make the points look like this again. It'll also deselect them, but then your decision tree won't have colors to them. So all that good stuff right here, and let's do some decision trees. You want, just so it's very clear, you do want this in your screenshot, you do want the scatter plot, and then you do want the output down here. Literally everything I have should be somewhere in your report. This whole thing right here, all the way down to parameter estimates. You don't need the lack of fit. That's testing to see if the line's the actual correct model. And you don't need the analysis of variance. That's an ANOVA, and we don't do ANOVA in this class. So we do similar things to ANOVAs because there's so many topics, so many great topics. Okay, we got that. We see our R-squared interpretation in the background here, blank percent of the variation y explained by the variation x. And let's hop back in, back to, so which variables act as identifiers? It says to remove those. Great question. Well, you know what? We tell people to answer that in Stat Lab, so let's do it here. I need some help. You know what we can do? We're going to do it the hard way. Now, this is the way you would do if you really had no idea. You'd take all your... Wait a minute. What does that say? Wait. This variable is a... They're telling me something right here. Almost as though Q0... I need to click the button. Q0... Q0 is an identifier. We have some fun here online. Q0 is an You know that randomness button quite well. Q0 is an identifier. Thank you, Jason, for making that button for us. And so guess what we're going to do? We're going to go back here. We're going to delete it. Deleted. Delete. Awesome. Now we're going to go back and do what we're going to do, but we're going to look through. Here's what I'm going to do. Do not put this in your report because you will be like, what is all this output? I'm going to select every variable, Control A or Command A on a Mac. I'm going to click Y columns, and I'm going to click OK. So if you notice, I'm going to go up here to the very top. I'm going to click Stack. Yes. Awesome. Ooh, it's all the way off the screen. We're going to go back to here. Gender is quite fine. Age is quantitative. And let's be very specific. Things that act like identifiers are things that have multiple levels, like way too many levels. Like if you ask someone their favorite restaurant in Knoxville, Taste of Thai, we've got, I kind of think of the other one I really like, Taste of Thai, a Hard Knocks Pizza, all these great ones right here. Great places to eat. Stock and Barrel Burgers, so many good places. People are going to start saying Nama. People like Nama in the chat. All these good places to eat in Knoxville. So with all this right here, you notice we'd get a lot of answers. And so if you're like, oh, the person who likes Taste of Thai, you'd be like, oh, I think that's Brian. Chayo's. Yeah, Chayo's great. That's in the fort. And so all these great places to eat, it might identify someone, be like, oh, that's the person who likes Taste of Thai. And you're like, that kind of identifies them. Now, it's not an identifier because it might repeat. If something can repeat, it's not an identifier. Now, if also something's quantitative, it's not an identifier, unless we're using like numbers like you're number 1, you're number 2, and that's just like an ID number. So that would be an identifier. So that first one was an identifier, especially since it told us it is an identifier, but age is not an identifier. Even though age has a lot of levels, it's quantitative. It's just a number. So now we have born in Tennessee, relationship status, distance from campus, high school GPA, Greek life, family order. None of these have too many levels. Nothing going on too crazy here. What is this? Oh, I think we found one. It looks like Q14 has way too many levels. This is going to really hinder a decision tree. We're doing a little bit of talk on how decision trees work right now. Take a huge note if you didn't know this. Decision trees take categorical Ys and categorical X's. Decision trees, let me say it correctly. Decision trees take both categorical and quantitative Ys, and decision trees take both categorical and quantitative X's. But decision trees should not take identifiers or things that act like identifiers. Something that acts like an identifier is something that would have a lot of levels. So that is something that acts like an identifier right there. And once again, decision trees take a categorical or quantitative Y. Decision trees take a categorical or quantitative X. They do not take identifiers or things that act like identifiers. And what is a thing that acts like an identifier? It's a categorical variable with way too many levels. Let's see. Good. Oh, all these are great. I mean, not too crazy. Nothing too crazy going on right here. We'll slow down when we get to the 40s. So as we keep going down further, nothing too crazy. You might say, Brian, this looks like, well, that's quantitative. It's how much did you spend on your most expensive coffee? Say, wait a minute. Cheated in college. Well, that's quantitative. How many times did you cheat in college? It's a quantitative variable. It's a quantity of how many. And all of a sudden we see, here we go. Boom. Another one. Favorite phone app has so many unique levels to it that it would act as an identifier. So I think we found it. Original row number, major, and favorite phone app are things that just have way too many levels and act like identifiers. So that's got it right here. Now I'm trying to think. Let me do this. Do I have the Q11 survey on here? Because I don't want to do one that everyone can do. Let's see. You know what I can do? I can use the haircut data. So we're going to use the haircut data for Brian to make his decision tree list. I want to find out with a decision tree why people are paying with card. So I'm using a different data set because I don't want anyone to do what I'm doing, lest everyone watches the video and does exactly what Brian's doing. So we'll really know if you do this with my data because we're like, why did you use data 1, project 1? So this is project 1 data right here. We're in a different data set, but we're going to make a decision tree and talk about the analysis of it. So let's go here to Analyze, Predictive Modeling, and go to Partition. Now, here's what we're going to do. This would be a lot bigger if you had more stuff. I'm going to select everything. Now I hit Control A or Command A to select everything. Remember I said I want to do a payment method. I'm going to hold Control or Command, Control on a PC, Command on a Mac, and I'm going to deselect payment method. Now, if you can't get it deselected, you could just go here and select it by itself and put it over here. But we're going to hit Control A, select everything, Control A or Command A on a Mac. So Control A or Command A. Hit Control or Command and click on it. So I'm holding with my hand right now. You can't see off screen. And then I click on it one time. That deselects it. I'm going to go over here and click X. And then I'm going to go here to Payment Method. I'm going to put Payment Method over here. Now, one important thing I want to mention is you should have removed those other variables. I know I'm jumping around a little bit, and I'm sorry for that. But if people are following along, hopefully they've gone here and they've gone to Major and go Delete. You won't need it again. Don't worry. I mean, if you were really, you could bring it back if you wanted. And then we'll go here to Favorite Phone App, and we'll go Delete. It's gone. So when you add in everything right there, exactly, we're going to do that right here. Lauren, we are going to analyze that and do it well. Great question. So I'm going to make my decision tree off of this data. And we've got payment method. This is a 2-level, which is what you're doing. Make sure you have a 2-level categorical variable. And let's see right here. We're going to color the points. Now, I want everyone to think about this. The people, awesome. This is great stuff. We're going to help everyone out here. I'm going to take this output, and I'm going to go split, split, split. I got a symmetric tree. Lucky me. Now, if your graphic is too large to take a screenshot of, hold Control or Command Shift, Control or Command Shift, and hit minus or plus. So as everyone see, I'm holding Control Shift or Command Shift, and I'm hitting minus or plus. I'm going to take my screenshot here of this. Let's take my good screenshot. Snipping tool is broken. Yeah, it's working. And we're screenshotting. We have our screenshot. We're going to bring it over here to a Word document. We're going to drop it in. We can do some adjustments on this. Looks pretty good on the page. We're going to make it smaller. It can get pretty interesting. Some decision trees will look a little bit crazy. Sorry if yours looks a little crazy. It's just the way sometimes stats do that. We're going to go here to Leaf Report. And please, if I do something too quickly, don't forget Maggie. Great job. Maggie, 1,000 points right there. We've got our Leaf Report right here. And then we're going to go back to Snipping Tool. Where did my Snipping Tool go? Oh, looks like I'm looking at the output, but Snipping Tool. And then we're going to go here to Leaf Report, and we're going to select the Leaf Report, and we have it. It went off the page, but I want this all to be on one page right here, so I'm going to make this a little smaller. And here we go. There we go. So now I've got a nice one-page output that when we talk about it on our project. So yes, too low means yes, no. Is favorite social media platform probably has a lot more than 2 levels. If it's 2 levels, you will only see over here, let's make it clear, when you make it, you will only see 2 levels to it. So you will know for certain, I believe that is more than 2 levels because there could be a lot of answers to that, Lucas. Great question, Lucas. So you'd want things like, have you broken a bone? Have you been arrested? All those different things right here, the different kind of questions you can use that are 2 levels right there. Great question, chat. Thank you so much. Feel free to ask those questions. I watch the chat at all times. So what do we see right here? Well, here's what we need to know. And don't put this in your report, but let's make sure we know how to analyze this. This is going to get us ready for the test. Right here is leaf number 1. Here's leaf 2. Here's leaf 3. Here's leaf 4. And there's space pen. 2-level categorical is something like, do you pay with cash or card? It is a Y variable that only has 2 levels. To get the points colored, click the color points button, which should be right here. I no longer have the color points button and it makes it easier to read. You shouldn't get points off if you don't color them, but it makes it easier to read. So click that colored points button and you'll have it. Can the variable be like, were you in Greek life? Yep, that is a yes, no question. So great job right there, Zach. So you're welcome, Abigail. This is what's so great. It's like I can answer so many questions. Gosh, do you guys like this online platform? Do you guys like, we're here live every Wednesday and especially next week, with the test. So Zach says he likes it. Zach's the only one. Maggie's there's 2 people, 3 people. We're at 4 people, 5 people, 6. Awesome. I'm glad you guys like this. It's really easy and there's gonna be a lot more of this. So I'm really glad. Thank you guys for being here. So awesome there. Oh, so awesome. Seeing everyone, Christina and Sydney and everyone, Zach and Abigail in the chat. It's awesome. Let's take a look. Do you remember what I marked on here at the top? I marked 1, 2, 3, 4. Now, I want someone to tell me which of these, 1, 2, 3, or 4. I'm sure I did, Zach. Zach's having fun in the chat. Which of these leaves is the smallest? 1, 2, 3, or 4. Which of these leaves is the smallest? 1, 2, 3, or 4. Which of these leaves is the smallest? And I'll show you how to do that in a moment here, Catherine. I'll show you how to get it into Excel in a moment. So we'll do that right after this one. I think we're doing categorical. Leaf 2 is the smallest. Does everyone... Oh, we were supposed to do a highlighter, and we didn't. Here we go. Here is leaf 2. Leaf 2 has the least amount of data in it. So let's look right here. Leaf 1, leaf 2, leaf 3, and leaf 4. Leaf 2 had the least amount of data in it, and leaf 4 looks to have the most. If you notice how I do 1, 2, 3, 4? Well, the same thing down here could be done. We go down here to the bottom and we go leaf 1, leaf 2, leaf 3, leaf 4. And remember, leaf 2 had the least amount of data? Well, for those, let's look at these 36 people right here. For those 36 people, 20 of them use card and 16 of them use cash. And it's pretty interesting. Can I choose Greek life and entire so I can choose it again for my tree? If you have Greek life, you can't then use it in the tree. You can use it in other questions, but it won't appear again in the tree. You shouldn't have it as an X variable. Because does Greek life explain Greek life? Yes, Greek life explains Greek life. So we wouldn't use an X to explain the same X to explain a Y. Good questions right there. Okay. So now let's do some analysis right here. Let's look at this first split. What does this first split tell us? Well, when you go right here and you split the tree, you'd split here and here. This is the very first split of the tree. And it looks like people who tip $6 or more, let me show you exactly what I'm talking about and highlight it. People who tip $6 or more were more likely to use cash. Do you see how cash is blue? Because the top points, the high ones up there, are blue, and then the low ones are red. So the people who are giving the big tips, $6 or more, and how do I know it's $6 or more? It says tip amount greater than or equal to $6. Just read it like a sentence. The tip amount was greater than or equal to $6. These people, when you look at them, this right here is the amount that used card, and this is the amount that used cash. And just estimating, it looks like this is 25%, and this is 75. I'm estimating. I could figure it out exactly. Why not show you how to figure it out exactly? This leaf right here, be ready. This could be test questions. I haven't seen the test yet, but you never know. This leaf right here that I'm pointing at is made up of leaf what and what. It's not really a leaf. It's kind of a joining spot. That is made up of leaf what and what. That is made up of leaf what and what. Think about what goes back into that. That is made up of leaf what and what right there. Those 107 people are made up of leaf what and what in the output down below. Those 107 people are made up of leaf number blank and leaf number blank. Look at down here. Which leaves go back into them? Which leaves go back into that group right there? Leaf number 1 and leaf number what? What leaves would go back into this right here? Leaves number 1 and leaves number... Someone's got to say in the chat, I'm stuck. I don't know. What comes after 1? Leaf number 1 and leaf number... Oh no! Leaf number 1 and leaf number... When I have like 150 people watching me. Yes, Abigail! 10,000 points, Abigail. Leaf number 1 and leaf number 2. And if we notice right here, there are these people who used card. So these people right here represent 33 people. Let's make this very clear. And we should know how to analyze this. These are 33 people right here. These are 33. And these people over here on the other side, the cash people, if I add 58 and 16, that would be, and tell me if I get it wrong in my head, that'd be 74. So these people right here are 74 people. So, make a little better arrow. These people are 74. So we can do the calculator right here, and we can do 33 plus 74. and we get 107. So 33 divided by 107, it's actually 30%. So it's basically, or 31%. So 31% of these people, and we don't have to go this in depth on it, but you never know it'll appear on the test because it might say like how many people, we've done this in the past, who tipped more than $6 paid in card. And the answer is, well, this is a component of leaf 1 and 2. Does everyone see how leaf 1 and 2 are all the way down here? So you would add back up the people in card in leaf 1 and 2, and these people are the people right here. They would be the people right in there. Does that make sense to everybody? That's generally, I think, one of the hardest test questions we ask because it involves knowing like what all the output means and how to utilize it. If you notice, we're practicing doing this as we work on the project right now, knowing how to read this. But once again, I'm going to go back to analyzing this first split right here, which I'm sure everyone's like, and tell me about that first split. What's going on with that first split? Well, in the first split right here, we see that it splits on whether people pay with, it splits on how much people tip. And the people who tipped $6 or more were much more likely to pay in cash and less likely to pay in card. The people who tipped less than $6 were way more likely to pay with card and less likely to pay with cash. Just doing that right there. So it seems to me that there is some sort of association between paying with cash and tipping more. And so, yeah, it's or tipping more and paying with cash, because we're trying to explain why people pay with cash or card. And so if people tip more, it's more likely that they paid with cash. Question 4C says to use the variable you selected in Q2. Yeah, you are all right if you use a different variable. We actually updated the instructions last night. That's a good way of doing it, right? So we updated the instructions last night, and you notice it might say version 4. So you are probably, it's all right if you use the same question or if you use a different one. So it was an update. Place the variable selected in the Y response box. So we updated it right here. This is, it was causing a little bit of confusion. Sorry, I didn't write a perfect project. I'm sorry. But great question right there. You can use a different variable. And so we updated it to make that clear. But you will not be getting points counted off if you use the same variable from question 2 because the project said to do it, even though it says, and I know the confusion right here. Oh, I can't. Okay, I'm going to enable edit. It says to use the same variable, but it says to use a 2-level categorical of your own choosing. So for analysis on the project, is it sufficient to say that there is an association between paying in cash and tipping more, as seen by? I would say it seems to be there is an association with paying in cash and tipping more. We noticed that the first split shows that people who tip more are more likely to pay with cash, and people who tip less than $6, people who tip more than $6 or more are more likely to pay in cash, whereas people who tip less than $6 are more likely to pay with card. And that's what we would use, Maggie, right there. And remember, I was using data that we won't use for this project, but that would kind of explain what's going on there in the first leaf right there. So great job. Brian, if you can, the for loops for 7F on, yeah, we might need to do that here soon. And that one, is that the boot one? Is that the boot one, Christian? Might need to do that at the end here. I'll probably be doing that in maybe another 45 minutes. Check back, Christian, and we'll be checking that out. Everyone likes the live videos. I really appreciate it, having so many people here. Christian, we're making you a mod. You are now a mod of the Stat2One channel. So if anything crazy happens, you got control of it, Christian. So you won't be able to upload any answer key. We don't upload the answer keys. It's just, reason being is we kind of have the one key out there for a project or an exam we've done in the past. But come to office hours, come to your teacher. If I'm not your teacher, come to your teacher's office hours, talk over the exam. We'll give you every answer. We might even show you the answer key. We've just kind of never had a policy uploading the answer keys to each test, but we will go over every test with you and explain every answer and ask all the questions. And especially if you see my office hours are busy, you can ask people in the chat, just be like, hey, Brian, I want to go over my test. That's usually a top priority. So usually it's like test, project, homeworks. And so if someone comes in to talk about the test, I'm usually like, let's talk about your test. I even today left for a moment and like talked to just people specifically, about 6 or 7 of them, just about their exam, and went over it with them to make sure they understood every question they had, and we saw if everything was graded properly. So great questions in the chat, and I appreciate it. So let's go on. Yes, it is the bootstrapping one, but if you don't have time. Oh, that's awesome. I think we'll do it towards the end, Christian. Great question. Catherine had a question about exporting data. Catherine, are you using a Mac or a PC? I think it was Catherine. Yes. So are you using a Mac or a PC? I don't know. You might see something different than me because on a Mac, you need to go to export. You need to go to File Export. On a PC, you can go to Save As, and you can just go here to CSV. So you're using a Mac. I have a video on how to do it. Go to File Export, and you should have the option to export as an Excel file. So go to File and then Export, and it should have like Export into Excel, and you might need to save as a CSV to do it in Jump. I do not have Jump, which is my issue, I think. Then I'll send the file to you. Send me an email and say, hey, Brian, send me that CSV file. I'll send the CSV file. I mean, I could say it's more work to say download Jump and then do it. Just say, Brian, send me an email, stat21.ut. No. Everyone knows stat21 dash your initials dash title here and say like send me the you're welcome. Can you determine statistically significant if it is due to the R-squared value? Great question, Maggie. The R-squared is the percent of variation in Y explained by the variation in X. So we actually see an R-squared on the tree. Let's make sure we know how to interpret this. This could be a test question. You never know. So when you look at the R-squared right here, this tells us nothing about statistical significance. So this would be 21.8% of the variation in payment method is explained by the tree. Take that note down if you don't have it for the test. To interpret the R-squared on the tree, it's blank percent of the variation in Y is explained by the variables in the tree. So in this context, it means 21.8% of the variation in payment method is explained by the variables in the tree. It explains some of it. I mean, like, yeah, if people are, let's see who's using cash. It is people who tip more who are not married. If you notice right here, this blue group all the way down here is using cash a lot, and these people are using cards. So this group down here, the first leaf, is primarily using cash. The leaf over here, which are our not tippers, these are the people not tipping us. We get less than $4.50 from them. They are primarily using card. So a big thing right here, this right here is the level of your Y variable. When you go through the tree, make sure to read it as though these are people who tip $6 or more dollars. It might be hard to see and make that clear. Let's do it again. These are people who tip $6 or more dollars, and these are people who are not married. So this leaf down here, these 71 people in leaf 1 are people who tip 6 or more dollars. They are not married, and also they primarily use cash. And I'm looking at what I've highlighted right there. I'm having issues displaying the bar chart for the question 2 on my Mac. Have you already gone over this? Great question, Lucas. Let's do that. You might be in night mode, but I've got a solution for that. We've got a solution for everything today. Okay, let's hop over here, and thank you to my students who showed me this solution today. So check this out. You ready, Lucas? Follow along. We'll get your graphic looking great. So I'm going to go ahead and pick a different variable than you right here. I'm going to go to Graph, I'm going to go to Legacy, and I'm going to go to Chart. So I'm going to pick a variable like Distance to Campus. You can double-click it. It'll go in the right spot. And then we click OK. Now with this in mind right here, you can see all the levels of distance to campus. We're going to click, am I totally in the classic view? Do I have jump 14? 2 seconds. I think I'm using jump 14, which does make a difference. Do I not have jump pro 15 on this computer? Jump pro 15. Am I Googling it? Do I have jump? I have jump pro 15. Yay. Okay. And then I just downloaded this data here. So that's a bummer that it opens with 2 seconds. File, open. Cool. Okay. Let's show what everyone will see on theirs. And so let's do it like you guys will see. You ready? Let's go here to Graph. Let's go to Legacy. Let's go to Chart. Awesome. Maggie, glad to help you out. We're going to go to Chart, and this is what you'll be doing. I'm going to click, make it bigger so everyone can see. And we're going to go to Distance from Campus, double click, we're back. And now when we click the menu, we see, am I still in jump 14? Feels like jump 14 for a moment. Well, let's do it this way. Graph, Graph Builder, and then we'll do it this way. Here's the interesting thing, which I even learned today. I've got a lot of ways of doing this. Really, high school GPA, you want to do that? And then we'll go right here. And then this is what we're going to do. We're going to full screen. We're going to go here to stacked, and then we're going to go to N, and then we're going to go to labels, label by value. There we go. I might have done it really quickly. Oof, that is too big of a graphic. We do not want the graphic that big. That is crazy. No wonder I've seen a lot of people making really big graphics. Wow. There we go. Oh, is it doing that because of the 24? That's interesting. That's fine right there. So Lucas, did that work when you went to the stacked option on it? Did that help? For some reason, the stacked makes it appear. Just learned that today. There's another way of doing it. It does say you can make any one of your choosing. Here's a really quick way. Distance from campus in the Analyze platform. And guess what? If you look at these two graphics now, so we'll get them side by side here. These two graphics do the same thing. So I've made two graphics right here, and you got the numbers over at Lucas. Great question asking. I think Zach has a question here. Question C says use the same variable. Yeah, ignore that, Zach. Sorry, that is a correction that we added. If you happen to use the same variable, that's okay, and we will totally grade that as correct. Just an error on the project. Yay, Brian made a mistake. This screenshot right here, I do see one issue with it. Yeah, this one, there we go. Please notice that if I had taken my screenshot, I might have... Oh, you got to fix. Great job, Lucas. The original way this looked, I might have lost points. Does everyone see if I screenshot this? This is going off the side. So I'm going to work with this a little bit right here, and I might even add account access, but it doesn't say to do that. But this is just a really good display of data right now. And let me show you again how I made this bar chart, which you can make. It's just a categorical display of univariate data. I'm going to go here to Analyze. Under Analyze, I'm going to go to Distribution. I'm going to double-click the variable I want to display, like family order, and I'm going to click OK. Then I'm going to go up here to Stack, and there we go. There's a bar chart. So this is a bar chart of people's family order, and I could screenshot this, and it just shows me the counts and the percentages of family order to see, like, most people are the youngest and then the oldest. It kind of makes sense. If you're in a two-child family, you're either the youngest or the oldest. And, like, I'm the middle child, and there's not as many middle childs. Only 19% of people are middle children. So rare group right there. And only child is the rarest, with only 7.7% of people being an only child. I think that did the categorical displays. We've done most of the project right now. We did Tabulate to start. We did univariate categorical. We did a lot of other stuff. Any other? Ask a question if you have it. So to clarify, we picked this. We picked the two-level category. Yes, yes, that is correct, Zach. Great question. Middle child right here. All the middle children. So you pick a two-level categorical variable and use it all throughout question 4, such as like gender or like fraternity, which is Greek life, and anything that was recorded as a 2-level. It could have more than 2 levels in the background, but let's say there's something like did you win a game, lose a game, or tie? But if there's only 2 levels, then you can use that right there. So what other questions are there? Been a great stream today, everyone. I think, how many people do we have watching? Feel free to ask a question if you have it. I'm going to see how many people are watching. How many people are watching? I'm interested. 23, that's awesome. 23 people watching live, I like that. Feel free to hit that like button. I'm going to ask everyone, hit the like button. Or hit the dislike. Someone's going to hit the dislike now. And we might have had some random people joining in and watching, who knows. It was really cool. I like when we see the random names. You don't have to use your real name in chat. For class tomorrow, will we go over chapter 13, quiz and homework for a bit? I think we got a lot Calzone! We won't leave yet. We won't leave yet. How are you doing lately? For question 2D, how do you identify the relationship? Let me look at that. Calzone, always good to have you. Our favorite mod, Calzone Tyrone, here in the chat. You are number 1, Calzone. So, yes, let's look at the project. We're doing project 2. We will have another Kahoot coming up here next week. Get ready for Kahoot round 2. I think it'll be on, we'll probably do it on, do you guys think Wednesday would be really good? Should we do it on Tuesday or Wednesday, the Kahoot? Tuesday or Wednesday? You know what we could do? We could do review on Wednesday, and then we could do Kahoot right after it. Everyone's going to be like Kahooted out. So, and then Thursday I'll probably, Thursday's going to be crazy. Wednesday Kahoot. So we'll do Wednesday Kahoot. Wednesday I'll come up here, and I'll start broadcast. Wednesday works for Calzone, so we're doing it on Wednesday. So open up the Tabulate and see, look at this right here, to see, include it, and shoot a short write-up. Okay, cool. Let's do another Tabulate one right here. And so we're going to do Tabulate and take a look at what we have. So good. We'll do it on Wednesday next week. I might already have it scheduled, but if I have it scheduled, I'll move it to Wednesday because I put some stuff in at the start of the semester. Let's go here to Analyze. And we have Jason Cam tomorrow. I'm super excited about that. So get ready for Jason Cam. I think we get some Jason impromptu. Let's look right here at Broken Bone. Put Broken Bone in the row. And then we're going to go right here, and we're going to put... You want to come on camera?
I'm locking this door up.
You're locking this door? Do you want to say goodbye to them? Give them some Jason advice. I disappeared. Brian's disappearing. I'm just going to disappear in the background.
Hello? JMP. Enter numbers. JMP.
I'm a shadow now.
I'm so sorry.
Jason's the What'd you say?
I'm so sorry.
Jason's the executive producer of the show. I have no idea. Abigail said. We'll show Abigail's message. All right. I like it. Calzone's. You know Calzone, right?
Yeah.
Yeah. Jason's in the background a lot of times. So, awesome. Jason's here. Jason's back. Okay. Locking the outer door. I'm locked in. I have to stay here all night and broadcast Stat 201 all night. So, see you, Jason. So we'll have Jason Cam tomorrow. We've got Broken a Bone right here, and we're going to go grab gender. We're talking about 2C right now. Question 2C. You cracked me off, Calzone. You'll have to see that in the chat. They say Jason's like, it's so fun. So we have the variables right here. And here we are. Here are our variables. And so take a look. Boom. What do you notice? I want someone in the chat to describe for me the relationship between gender and breaking a bone using the percentages. I want to see a really good write-up in the chat. We did it earlier, but what could you tell me about gender and breaking a bone right here when it comes to the percentages? What do you notice about the relationship within the data when we look at someone's gender and whether or not they've broken a bone? And Abigail will definitely do some chapter 13 tomorrow. It's some tricky stuff. We got so much time. We'll finish chapter 13. Whoo! It's a whirlwind. And Thursday, I might just do online office hours on Thursday, like next Thursday. Does anyone have any idea what's going on here with gender? I see males and females, and I see whether or not someone's broken a bone. Like, no. Here's the percent of females who have not broken a bone. Here's the percent of males who have not broken a bone. Here's the percent of females who have broken a bone. Here's the percent of males who have broken a bone. So this is broken a bone females, broken a bone male, not broken bone female, not broken bone male. So what do we notice? 50%, 55% of males it's very close, very close. While 61% of those are not it's not that they're not likely, it's that they haven't broken a bone. Very good job and very close. So excellent work, because you would say 55% of males in the survey had broken a bone, as opposed to, which is the majority of males. So the majority of males have broken a bone. 55% of males, we're kind of rounding it, have broken a bone in this survey, as opposed to 62%, we'll round that one up, 62% of females have not broken a bone. So it seems to me that males are more likely to have broken a bone than females. Does that mean every male has broken a bone? No. It just means males are more likely, according to this data. The data could be wrong, or it doesn't mean males do break bones. It just means, according to the data, we see a trend where males are more likely to have broken bones, with the difference, and we might take some differences here, but we'll look for a trend in the data to say, oh, we see these differences with the percentages, and this is real data, and so it's like, okay, it looks like males are more likely to have broken a bone, and females are more likely to have not broken a bone, due to the percentages. And quoting the percentages is key. Please quote the percentages. Please quote the percentages. I can't say that enough. Let's take some more questions here. We'll try to go at least till 5. Let's take some more questions. And if Christian's still here, we might do that question in class. I think it's the bootstrap resampling. I'm thinking how that one works, because we're going to take some bootstrap resamples, and I guess we're going to go through and we're going to see how it works on multiple bootstrap resamples. Hey, Christian, is that it right there? I think that's, and if you're 201, feel free to ask. I'm going to pull it up in the background here. Let me go get that question. And I think the output's kind of already half made for us, right? Doesn't that one start with output half made? Let's see. And you guys know I do like some help in these videos on the 474. I show some like, let's show a little bit how to do that. Let's be able to start it. And Christian's here asking a great question. So we got so many tests coming up. So many tests. It's like we got to write tests. That's exciting. So we're opening up RStudio here right now. I'm going to install the packages. So I haven't used this computer for everything yet. The new RStudios will do this right here. On Chapter 13, Quiz 2, Part C asks how many students are expected to be nearsighted. It says to use the equation of 3 standard deviations plus or minus the mean. I'm unsure what to put into that. So we're going to do that one real quick right here, and then we're going to come back to this, Christian. So just a second, and we'll come back to this. So we're going to do a tiny bit more 201. You know what? Because we could do a bunch of those 201 questions right now, and then we'd have it out there. So let's take a look at these 201 questions right here. We'll come back, I promise. And I have some people who might be coming in to watch the class at 5. So they're saying, we can't show up till 5. And I said, okay, we'll try to make it till 5. I'm going into my Pearson right now, and 2 seconds, I should be in here. I'm just clicking through some screens. And chapter 13, this is the first one right here, and we're doing sampling distributions. So is it the homework? I think it's the homework. So okay, let's bring back up the chat. Homework, awesome. And let's find it right here. Oh, is this it? I think we found it. Boom, we got it. Okay, so with this problem right here, we have 3 conditions. We have random, 10%, and success failure. So when we look at this, we should know how to do success failure. Success failure is going to be NP times NQ. Now, I want to kind of go through this slowly and talk about it here. Let's take a look at what this question tells us. This question tells us some summary statistics that we need to use. So when we look at the question itself, let's identify key parts of it. And I think I can get most of it on the screen, if not all of it. So we're really going to focus in on the first part of it here, and let's see. The school knows that nearsightedness affects about 11% of children. So what is 11% if the school knows, and I'm kind of adding extra words, but the school knows that nearsightedness affects about 11% of children. So what would that be right there? That would be what if the school knows it? The school knows that nearsightedness affects about 11% of children. That's totally what I am. Nearsighted means that you see better up close. It means you put things in front of your face like this. So that's why I'm always like, I can't see. Nearsightedness affects about 11% of children. And what does that mean it is? What is that right there? In notation, what is that? Very important on the test. This is huge test help right here. To when you see something like this, circle it and immediately mark what it is. That is P. That stands for the true proportion of children that are nearsighted is 11%, which means P is equal to this right here. Next, we see N right here, which is the sample size we are going to take. So we know N equals 171. So we've actually got all the notation we need for the sampling distribution. We know that the sampling distribution is normally distributed with a mean of P and a standard deviation of P times Q over N square root. And that's going to allow us to draw this out right here and put P at the center of it. Good, I didn't hit myself yet with it. And then to go up and down standard deviations of P times Q over N square root. Very important we know where this problem is going because it gave us P, it gave us N. And you might be saying, what is Q? Someone in the chat, 100,000 points. Calzone, if you haven't seen it, we've got a new button this semester right here, and you know what it is. People know it's about to come on the screen. And where is it? Oh, no. Oh, it's right here. Yes, Abigail right there, you earned those points. So if you know what P is, you can know what Q is. So exactly, P is that, and Simon right there, I'm giving it to Simon too. You get the 100,000 points. And so we go right here, and that is Q. So we play a game called the P and Q game that if P is equal to 0.2, Q is equal to what? Just do it in the chat. Do it with me here if you're watching this video. P is 0.2, Q is what? P is 0.2, Q is what? 0.8. P is 0.4, Q is what? P is 0.4, Q is what? P is 0.4, Q is what? 0.6. Nice job, Simon. We just need to know P and Q like this, and if you don't know it, it's just 1 minus P is Q. They both add up to 1. So we should know P and Q pretty quickly, because someone could say, well, Brian, you know P, but you don't know Q. Well, they add up to 1. So 0.11 plus 0.89 add up to 1, so we know what P and Q are. Once we know P, we know Q, or if we know Q, we know P. So we can draw this out right here. We'll probably use David M. Lane to do it. It's just a lot easier. The conditions are random, which means we need to select random 171 kindergartners. I guess we do. We need to select less than 10% of all kindergartners. 171 kindergartners, probably less than 10% of all kindergartners. And then we need at least 10 successes and at least 10 failures. So the success-failure condition is found by doing NP and NQ both have to be greater than or equal to 10. So we have to find 11%. Technically, we only need to do this one. I'm going to do 0.11 because that's P and times that by 171. This gives me, I would expect, 18.81 kindergartners to be nearsighted. Now, that's not percent. It's weird because it's like you can't have a 0.81 kindergartner be nearsighted, but it's like, well, it's what we expect, but there's going to be variation around that. It's not going to exactly occur like that. And then, of course, if you times this by 0.89 and do that, you'll get the other side of it. Both those numbers we just saw would add up to the sample size of 171. So I think the other number was 18.79, was it? I think it was 18.81. Yay, I was right. That was the other number. And if you notice, they add up to 71. So NP plus NQ equals N because this is how many we expect to be nearsighted. This is how many we expect to be not nearsighted. And this is the success-failure condition. And since both numbers were greater than 10, we passed. Listen to those key words. Since both NP and NQ were greater than or equal to 10, we pass. I found that NP was 18.81, and I found that NQ was 152.19. Both of these are greater than or equal to 10. We pass the success-failure condition. 10% condition means we need to sample less than 10% of the population. We've sampled less than 10% of all kindergartners. We're good. And random means we've randomly selected kindergartners. We're good. Okay, let's look at these questions real quick on it. Assume that these children are typical. Yeah, I think that's it. Woo, good. Yes. Now, this is one that trips people up right here because this is 3 standard deviations. Anytime you look at this graphic, it's doing 1, 2, 3. It doesn't do the other numbers on it. I'll post it here after class. Simon, thank you. 10,000 points for reminding me. I was doing some grading yesterday, and time got away from me. So when we do the center of this curve, you might have noticed I already wrote out at the very center of that curve would be P. So what is P? It's 0.11. So now all I need to do is find the standard deviation. The standard deviation is going to be P times Q over N square root. And so standard deviation is 0.023. I'm going to times that by 3, and that is 3 standard deviations now because I'm going to see what the values will be on this far side of the curve here and here. So I'm specifically trying to understand what values I would put here and here. So this is 3 standard deviations I found. And I'm going to go 0.11 plus this, and that's 18. So this is about 18%. That looks horrible. %, and then the other one should be about, my brain is breaking, 4% or so. Let's find out. Yep, about 4%. I'm rounding it just for the time being. So that's what we get right there, about 4 to 18%. Let's go back to the MyPearson graphic. And if you look, there's the same numbers we just saw. We got it. It's doing 3 standard deviations. It's not just 1 standard deviation, so you have to multiply your standard deviation by 3. If you want to see the individual standard deviations, it's 1, 2, 3 standard deviations. So I multiplied what P times Q over N square root by 3. So good stuff right there. Continue on with the question. How many children would we expect to be nearsighted? Somewhere between about 4 to 18%. So what is 4 times 4%? I guess we could have used that number. So that's 6.84. So that's basically 6. And then the top number would be 31 because it's showing 18 as that's the high number. And that's 31 right there, as we said. And that has got it. Did that help out right there, Abigail? Does that make a good bit more sense on it when we worked that question? And I want to point out something. Please try, if you have your notebook out, please try to draw the graphics. Please try to take the notation. It really helps with working the question. If you do like your own kind of sample drawing of it, like it's a test question, then when you get to the test question, if we say draw the sampling distribution, you'll have practice. My Pearson will show you the graphics and have you select the right one. But if you draw it out yourself and you're like, this is the graphic. How did you get the 0.04? We had to find the standard deviation. Great question, Abigail. We had to find the standard deviation. So I'm going to find P times Q over N square root. So here's P times Q over N, and then square root of the whole thing. It's not over N square root of N. P times Q over N square root. And so this is one standard deviation. And if you notice, I'm going down 3 standard deviations. If you watch me going down that way, I go down 3 standard deviations. So that's 3 standard deviations. At the very center of this curve is P. P is equal to 0.11. So P is 0.11. So what are we going to do? We're going to take 11 and subtract from it 3 standard deviations. And then we're going to take 11 and add to it 3 standard deviations. Then I've rounded the numbers a little bit. So if you notice, I'm adding 3 standard deviations. Each one of those little spaces up and down is 1 standard deviation. Does that make more sense, Abigail? Do you understand how it's, we find the standard deviation, we multiply it by 3, and then we add and subtract that to the center of the curve, which is P. Yes, nice job, Abigail. Great job. I love seeing these answers in the chat. So hopefully that helps out with finding the right graphic right there. And then these are the percentages we would expect out of 171 children, kindergartners, to be nearsighted. Amazing work. Let's see. Going over here. Question 7. Why don't I ever use these buttons? They're always right here. Okay. So, is this question 7? Wait. That's not question 7. K-fold, bootstrapping, fun stuff. Okay. Got train data, all this. Oh, I have to run the top thing. 2 seconds. Hopefully everything runs. Christian, are you still here, Christian? And if anyone else has questions, feel free to ask in the chat. We're just here doing our Wednesday classwork. Tell everyone, be like, hey, on Wednesday, you can come live on YouTube and ask Brian questions. I'm usually here about 3:45 or so. So check out the channel, subscribe, like, all those good things. Hit that bell for notifications. All that good stuff. And so let's see. So use the results from B, create a data frame called pseudo-train, which are the rows in train that appear in the boot train. Create a data frame called pseudo-holdout, which contains all the rows in train that do not put the train. Verify the sanity checks. So we've got sanity checks, all good stuff. Using the LM function out the train for the multiple regression model predicting price, using all the predictors, no actions on pseudo-train. This stores prediction on the holdout in the same vector called this. Produce a summary, blah, blah, blah. Use the predicted value. Where is the for loop on this again? Where is the... Now write a for loop. Oh my gosh. Okay, let's go to the for loop. I'm going to be doing the whole problem here. So let's go to the for loop. Now write a for loop that finds the RMSE of the models trained on 500 bootstrapped training sample models. You've already written almost all the code. So that's the whole point of it. The for loop part. I might not do all of this because obviously it's kind of building it all up. I pretty much have to do the whole question of it. Outside the for loop, initialize this. So here's the... Let's do this. How do we initialize something? So that has been initialized. So set up the loop so that your looping vector is the integer sequence this. So we're going to go, I will go through vector 1 through 500. For those wondering, this is not the answer, obviously. But what goes on here? Oh, I did capital I. Well, wouldn't you know it? I hit caps lock. I was like, why didn't that work? That just will print all the numbers because all I have it doing is printing I and it changes what the I does. Store into the ith element in boot RMSE, the RMSE found from doing the ith time through the loop. So we have to go through here and we need to go to boot RMSE. We need to store into ith position of it. We need to go here and let's think about how we do root mean squared error. Okay, this is very important right here. We actually don't have everything we need yet, but I'm going to kind of write some of it right here, and I'm kind of doing a good bit of this now, and you probably have other parts of this. The first thing you do when you do this is you need to create a model right here, a linear model, and we would have our y variable right here, tilde, and are we using all of it? If you can't do the whole question, maybe just the setup of the for loop. Yeah, and I think this should help out Christian right here because, I think this will help out a good bit, and I'm kind of writing it all right here. So I'm doing a good bit right now because we have here the linear model is being created and stored into something m, and we have the y variable, and so the y variable is just what we're predicting. Could be price, could be anything. It's just whatever y variable we are predicting. And then are we using all the x's? We could use individual x's like x1 plus x2. We could use different x's, or we could use all the x's just like that. And then we have data equals, and we got pseudo.train probably. So this right here says take all of your variables and predict y using the data set pseudo-train. Does that make sense, Christian? And then we're storing that model into something called M. Now what I'm going to do is I'm going to call this predictions, and I'm going to go here to predict using model M, and I'm going to say new data equals, and I think we're just doing holdout. Are we predicting on a holdout, or are we predicting on a pseudo holdout? I think it says pseudo holdout, yeah. So prediction equal da-da-da. So yeah, we're using a pseudo holdout. So we're going to go here and go new data equals pseudo holdout, and this will get the predictions right here. What does, oh yeah, we'll hop back to that right there. Great question. Don't worry. Sorry about that. The word it gets mad at. It gets mad at that right there for some reason. Sorry, someone else did it earlier. Streamlabs is just being a little bit crazy. So with this right here, Christian, do you understand what line 315 is doing? What is line 315 doing in the code right now? And this code won't work, but it's the nature of it. Everything I've written is like theoretically accurate on what we should do. What does line 315 do? What does line 315 do? What does line 315 do? Any ideas on line 315? What is line 315? Here, let's read through it. Line 315 will save into predictions. This is the save into arrow. It's going to save into predictions. Predictions made using the model on new data. So we're going to use our model that we just made on new data. So we're going to use our model we just made on new data. Now here's the biggest thing is we also have to make, let me put a hashtag right here. We need to make new pseudo trains and holdouts each time. So so we need code that makes a new pseudo train and a new holdout each time that this runs. So we're going to need that before it because we don't want to predict on the same thing. We're going to run this 500 times and see what happens. And then we go right here. And to store this, we need the root mean squared error. So breaking that down, that's the root, which is square root. And that's the mean. So that's the root mean. And then we need the squared error. So we need to go here and find the residual. So the residual here is going to be, you know what we can do? I'm going to do this. I'm going to go here and go residual. And residual is going to be actual minus predicted. So let's do this square residual. So the squared residual is the actual. So I need the actual value it was, which will be found in the pseudo holdout. And this, it might be, I think we're doing price. So that's the actual value it was. And Fisher, we got that next. Oh, no worries. We're going to do that next here. Great questions. And then we need the prediction. So we need right here the predictions. So, yep. This will take the difference of the two vectors. This will square it. And then we drop this in here. And that's pretty much it. That does this help out, Christian? This is the first part of the code, which I don't have right here, is going to make the pseudo trains and the pseudo holdouts. But does this make more sense about what's going on right here? I just stored the squared residual. For some reason, we had a little issue with someone's code. But my code on line 317, this line right here of code is storing the squared residual. And what is a residual? It's the actual price minus the prediction. For those who are in 201, it's actual minus predicted, and then we're squaring it, and we're actually making what's called the root mean squared error. So that's a root mean squared residual. That's the RMSE. So RMSE, which you see right here, stands for root, square root, mean, squared, error, residual. So that's the root mean squared error. So it's just a little bit of mathematics to find a model metric of how our model's doing. And I don't have the code right here to make the pseudo train, pseudo holdout. I don't want to do the whole question, but did this help out? Did this get you further along? And then we're going to answer Fisher's question here. And I think we've got Shiv has a question too. Yeah, good job. That's got most of it right there. So I always like doing parts of these, and this is the theoretical part of it right here, because each time this runs, it's going to store into I, but you do need the code that's going to make a new pseudo hold and pseudo train each time. So you should have written those codes that makes a new pseudo holdout and a new pseudo training each time. Then it makes your model, it makes the predictions, it squares the error, and then you have the same question as Fisher. Amazing stuff. Let's hop back here to 201. We're back to 201 world right now. How do we examine the first split in the tree to find the nature of the association? We've got some decision tree output right over here. So here we go. I made a decision tree earlier to understand why people pay in cash. Now I want to point something out here. The Y variable right here is what I'm asking. Why do people pay in cash or card? Don't worry, this has been a common question. Great stuff in the chat, and good to see everyone here with Shiv and Fisher. So good to see you. We'll talk through this right here. We'll read through this analysis and get ready because decision trees might be on the test. If you notice, I want to show my output off. Your pictures might be a little more crammed, but notice how it's nice and easy to read. When I zoom in here, it's pretty large, pretty easy. I know these outputs might get a little bit large, so don't worry if it's really hard to get on one page, but the better it looks, the better you can try to make it look, the better it is. So we often are a little bit forgiving, but if I were to have something on my project that looked something like, ridiculous like this, that's probably where we start like a little bit small right there, but so yes. Now let's do some important stuff with looking at this output right here. Right here, we'll notice that this is leaf 1, leaf 2, leaf 3, leaf 4. So do you notice how I just count 1, 2, 3, 4? And then let's go here and put 1, 2, 3, and 4. Guess what we're going to put down here on the bottom? This is leaf 1, leaf 2, leaf 3, leaf 4. Now you guys got to help me out in the chat. Which two leaves look to be the two smallest leaves on here? Which two leaves look to be the two smallest leaves? Any ideas on which two leaves look to be the two smallest leaves on here? Which two leaves look to be the two smallest? 2 and 3. Nice job in the chat right there. It's 2 and 3. And when you go down to here, you can see that there are 36 people here, of which 20 of them paid in card and 16 paid in cash. And then in the other leaf, there's 46, of which 27 paid with card and 19 paid with cash. Yeah, let's do that. We'll do that next year, Abigail. So we can look at all these leaves. We can see that the largest leaf is leaf number 4. And then when you analyze leaf 4, when we talk about it right here, is 79 people. The 79 people in that leaf, 66 of them paid with card, 13 paid with cash. Notice how these two numbers add up to 79 right here. And also these people tipped less than $6, and they also tipped less than $4.50. So if you notice, these people were more likely to pay with card. They swipe their card, they punch in the amount, and you're like, you didn't tip a lot. So if you notice, these are the people who tip the least amount, and they're more likely to pay with card. These people over here in leaf number 1, which is not our biggest leaf, but we can talk about it. Leaf number 1 are people who paid $6 or more in tip, and they're also not married. And there's 71 people in this leaf, and of these 71 people, 13 of them paid with card and 58 paid with cash. So when we go back and we look at the nature of the first split, this is the way splits work. Splits work the following way. You split at these locations right here. So this is your first split right here. Split 1, and this maybe was split 2, and split 3. So these are where the splits occur. So you kind of have a first split, a second split, and a third split. The first split has to be from the top of the data. It's like pipes going down. So the first split of the data would be, we noticed that people split on their tip amount. The people who were tipping $6 or more were more likely to pay with cash. How do I know that that's cash? Well, I colored the points. And if you notice, blue is cash. So this is over here in the first split. You can kind of tell if you're really good at reading this graphic. You can see this is where the first split occurred. You don't have to get that exact, but that's leaf 1, that's leaf 2. This is where the first split occurred. You don't have to be that exact, but the people on the split 1 and split 2, which you can tell down here, leaf 1 and leaf 2 go into that. And so these people in the first split up here, which I'm highlighting right now, let's make it very clear, the highlighted leaves and the circled is the split 1 and the first split, and they were more likely to pay in cash, and they also gave a tip that was greater than or equal to $6. The people on the right tipped less than $6 and were more likely to pay with card. It seems to me, finish my sentence, people who tip higher, larger tips, we would generally expect are more likely to what? Larger tips are what? From this, I would gather that people who give larger tips are more likely to what? From this, I would gather that people who give larger tips are more likely to... Any ideas? Who knows? Pay with cash. Nice job, Simon, right there. Pay with cash. Because you notice over here, let's make it very clear, that the tips over here, this leaf right here on the first split is the larger tips. And you'll notice that more of them were paying with cash than we're paying with card. Then on the other side, here's your card tips, and these are the smaller tips, and here's your cash tips. Seems to me the nature of the association, even using keywords like that, it seems to me the nature of the association that people who tip larger amounts are more likely to tip with cash. So that's got it. Abby asked, Abigail asked, can we do the converting a z-score to a doing p-hat into a z-score? Yes. So I like to ask this question a lot because I think these questions are a little bit easier than we make them out to be. If you've worked for a bank for a long time and you've given out loans for tons and tons of time, oh my gosh, Adam, great job on it. Great job, Adam. So if you give out tons of loans at the bank, and you notice 11% of people default on their loans, then what would you expect if you gave out 100? I love the positivity in the chat. This is so awesome about teaching online. If you gave out 100 loans, what percent of those loans would you expect? And that's what mu p hat means, is that I would expect to see in a sample what percent. So what percent would you expect if you notice that 11% of people don't pay their loans on time? Well, if you took a sample, what would you expect to see in that sample? Any ideas? It's like, well, if I notice 11%, probably expect in my sample 11%. You got it. So that's mu p hat equals p. And now you might remember the standard deviation formula is p times q over n square root. We repeat that a lot. And we just did one like this. There's p, q is 1 minus that, so that's q over n square root. So we do the square root right here. We don't square it. And then we take this and we put it in here. We round to 3 decimals. We hit enter and we got it. P times q over n square root. Now here's what I would do if I was doing this for test practice. I'd go over here and I would draw the sampling distribution. This is how to do test practice with these questions. So if I'm the bank and I'm giving out 100 loans, I would expect 11% of the people to default. Now the standard deviation we just found is basically 3%. So here's 14%, here's 17%, here's 21%. Does everyone see I'm just going, error. Here's 20%. I was thinking multiples of 3, and 3 times 7 is 21. So, but we're doing plus 3, and we're not doing it on a multiple of 3. And here we are right here. So 95% of the time, I would expect between 5% and 17%. That's a 95% interval right there. It's not what the question asks, but that's what that means because that's 2 standard deviations. The question wants to know the probability, and I did round the numbers. We'll use the non-rounded here in a moment. The question wants to know first conditions. Condition 1, random. Condition 2, 10%. Condition 3, success, failure. There's 11 expected successes and 89 expected failures. So with reasonable assumptions, we pass. Did they randomly take the people? Yes. Is 100 loans less than 10% of all the loans we give? Probably. And do we have at least 10 successes and at least 10 failures? We expect 11 successes. We expect 89 failures. So now it wants to know the probability of more than 17. And did I get an easy one? Let's hope. Oh, well, look where 17 is at. Now, here's what I'm going to do. we are truthfully about here somewhere, because this is like 17 point, I think it's 17.4. Let me look at the standard deviation again. No, it's 17.24. I'm just adding the extra decimals to that because we're not right on 17. Because if we were right on 17, we'd be almost at 2 standard deviations, and we're not quite at 2. I can find the z-score here in a moment, but it's a lot more fun. We'll do the z-score in just a second, Abigail, because that was your question. But I want someone to take a guess of the area. People always wonder how I get these right and guess them. They're like, how do you guess these? How do you do that? Well, think about this. What is this area right here above this red? What is this area above this red? How much area is that above the red? Hint, it's 2 standard deviations. Write your z-scores. We do test questions a little bit like this sometimes. So what is a guesstimate of that area above 2 standard deviations? And funny enough, I hadn't seen this yet, but remember I did this. So what is the area above the red arrow, which is a little shorter? There's the answer right there for what the red arrow is. So we have to do a little bit more than that. It's probably about 3%. I'm going to cross my fingers here. I get 2 guesses for free. Round to 3 decimals, so it's got to be 0.31. Oh, that was almost a fake guess. Yeah, we got it. That's how we do it. Who needs the David M. Lane calculator when you can just draw it out and figure it out? It was just really close to that, so I was able to take a good guess on it. So once again, it was a little bit more than 2.5 because the z-score is going to be like 1.94 or something. So Abigail did ask, how are we going to find the z-score? So let's show that. The formula for the z-score is, it's going to be p hat, which is what we observe in our sample, minus p over p times q over n square root. And so this is equal to 17 minus 11 over, and it was 0.0312. So this is going to get us the z-score, and then we'll show how to solve from here. So we take we take the number. I'll show the equation while we're doing it. There we go, a little bit easier. Take 17 minus 0.11, and then we divide that by the standard deviation. I said about 1.92, so 1.92, let me get the exact decimal on that. 918, or oops, what I copied? 176. There we go, right there. And so what we need to do now is we need to go back to the David M. Lane applet. Let's pull up David M. Lane. And with David M. Lane on the screen, we're going to take a look. We're going to go here and go above. And how close was I? It was actually, they were really nice with this. I was decently off, not really far. But luckily, the plus or minus on it was good enough that it gave it to me, gave me the right answer. You could also, you don't need to use the z-score. You could go here and put in a mean of 0.11 and do a standard deviation of, we have to find it again, p times q over n square root. This is what I call the in-context version of the problem, the contextual version. And then we go above 17. And look, here's something I want to point out to you. This graphic right here, people say, well, how do I do it on the test? It's a great question to ask. How do I draw? I can't use the applet. This graphic right here, what do you notice? Let's make this, there's a way, wrap text, in front, behind text. What do you notice about this graphic? Now, mine doesn't look as perfect as it, but what do you notice about the graphics right here? Mine has 2 thick of tails on the side, but if you notice where the line is at, it's right before where this is. So that's the important thing we should know, is that we can basically draw this out and do a decent visualization of it. I hate that the David M. Lane sometimes doesn't include the 3rd standard deviation, but if you know where these numbers are at, let's go to the red and write it below here. This is 0. I thought that was red. This is 0, this is 1, this is 2, this is -1, -2, -3. Does that make more sense, Abigail? Did this help out? And the formula being your sample proportion minus your true proportion times the true proportion and its complement over this, and this is equal to a z-score. And so that's how you can make it into a z-score right here to find the value right here, which then you can plug in the data. Yes, you're welcome. So great. I'm so glad. Yes, I so happy, and thanks for coming to office hours today. I remember so many of you in office hours. Saw Adam today, saw Abigail today in office hours, Christian today in office hours. Thank you, everyone, so much. And is there any more last questions? We've done a lot in this video. We did some 474, but I really love that you guys enjoy this and ask questions and are working hard, and that's why we try to do this right here, so you can get help and we can show things and how to do them. But that has got it. Tell you what, as per usual, I'm going to go. Came here off stars last minute. Wasn't sure if you're going to still be here. Yeah, and we got some stuff done. You're welcome, Simon. Have a great day. I tell you what, I'm going to go to my office and get a little work done. I'll talk to you guys later.
Hey, Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!